Docker start Unix. Okay, virtual box. Just gonna go ahead and get everything I want.
Okay, I'm gonna go ahead and start introduction.
If you wanna.
All right, everybody, we're gonna get started. We had a little technical difficulties, but I think we've hacked around them as true developers would. Just wanted to show everyone the backlog. Again, we have a number of we have a number of talks in the backlog. Anybody can present as little as 5 minutes if you want. We have a number of topics ranging from all type of things, from imposter syndrome to the blockchain, right? So anything you want to talk about, just let me know. We've in the past thought there was a topic that wasn't quite appropriate, and it turned out to be one of the best loved topics from the group. So if you have an idea, please let me know. Today we're going to be talking about container security, so that would be the topic here. And Mark's going to be our presenter for that. Upcoming, we have a SharePoint presentation on February 2nd. We have an MVP coming in for Microsoft MVP coming in to talk about that. We have a couple other talks that are in the pipeline. I think that'll be in January. We probably won't have another one until early January, given the holiday season. And frankly, I'm not going to be here. So we'll pick up then again after that. I think that's more or less it. There's a sign-in sheet coming around. Please make sure you sign in. Okay, and also the pizza is provided by the PAC contract. If you have any ideas on like how to help out with that, because I got we had 2 meetings, one last week and one this week, and when I asked for the pizza for this week, I got the response: how many of these people are actually on PAC? So we might have to talk about that after the meeting. So we'll figure out if we can like do some load sharing with that, so that I don't get the funny looks or funny emails from my contract. But we can still continue to have the meeting, and we can continue to eat, because eating is good. Right. All right. With that, I'm gonna turn it over to Mark, and he's gonna be our presenter for the day. I'm gonna hopefully get this to work properly.
Maybe not so much. Okay. Well, so I'm gonna. Okay, so real quick,
he's doing that,
can people hear me? I tend to walk around a lot, so they weren't kidding about that projector needing sunglasses. Cool. Who saw Star Wars last night? All right, cool. No spoilers, I promise. Okay, so real fun. Let's get to why people are here. Raise your hand if you've heard the word container. Okay, cool. Docker. Cool. Great. So who here has used a container? Okay, cool. So a little bit about myself for a couple of seconds here. My name is Marc Boorshtein. I'm the CTO of Tremolo Security. We are a startup here in the DC area. We focus on identity management. Last year or so, we spent a lot of time in containers. And Andre heard me on the PodCuddle podcast a few weeks ago talking about identity management and Kubernetes. Quick show of hands who's heard of Kubernetes? Deployed it? Cool, we're going to have some fun. My original plan was to keep this really open. I've got kind of 2 pieces, one of which is not supported. The first being just kind of a general talk on containers, security, what a container is. I'm going to bring up, there's a Google Doc that Andre sent me with a bunch of topics that people are interested in. So, and you know what, why don't I go ahead and pull that up right now? So that way, there was here we go. So want to keep this really open. You have questions, yell them out, scream them out. If you're going to throw something at me, I request that be a little soft. You know, one of the things that Andre had brought up that he had really wanted me to come by and talk about is, in addition to containers and security, life inside the Beltway is kind of special, right? We don't always operate with the same physics that the rest of the world does. And so really has this apply to the regulations that we all have to deal with when we're doing implementation. So you're talking about PIV, you're talking about all the various NIST and FSMA regulations, and kind of how you get that to fit inside of your world. So going first, let's talk a little about what a container is. There are questions on here around whether or not, containers are better than VMs or whatnot. So when people talk about what a container is, often refer to it as vials of unicorn blood, maybe boxes of pixie dust. Really isn't. It's a zip file. Technically, it's a tar ball. But that's all it is. It's a set of tar. It's a tar of tars that have a little bit of metadata. There are really two things that set a container apart from a VM. One is their size. They're small. You're only packaging the bits of your application that matter. And that packaging uses what's called a copy on write file system. So the idea being that every time you commit, just like in Git, right? You make a commit that's hashed. Same thing in a container. When you set a layer in your file system, so if you're using a Docker file, for instance, every single line in that file system is a layer. Every command is a layer. And then that layer gets hashed. So the nice thing is you can actually remove layers. You could put them in if you wanted to, but they're very, very small. So as an example, our software, Unison is the name of our software. When we used to deploy on what we like to call a virtual appliance, it was Linux, it was RHEL, you had a full VM. So you needed to have 10 gig minimum. You want to have some room for logs. You want to have room for the OS. You want to have some room for temp space. That's a lot of information. Whereas our container, between the CentOS or RHEL base image and our layer on top, it's like 400 meg. And I don't have to worry about providing space for logs. That's something you put on the host log. I don't have to worry about different libraries. That's handled all by the CentOS or RHEL base image. So it makes for a much smaller system. Also makes a very easy to scan system because everything's kind of standardized. So there's been an explosion of services that let you scan what's inside the container. Docker, what is often referred to as Big D Docker, the company Docker, has something called Docker Store, where ISVs such as myself would submit a container. That container would get scanned, and they would then compare it against the list of CVEs. Red Hat's doing the same thing. There are some private companies that do it, a company called Anchor.io. Real smart bunch of folks. They're doing an online service, a SaaS service to do that. And then Twistlock, I think, is another one. So there's a lot of different services for scanning. So the idea being that because this format is standardized, you can generate this container, you can put it into a private registry, and to answer the question there, yes, you always want to use a private registry for anything except maybe a demo. And I'll talk about why in a second from a security standpoint, but this is one of the big reasons that if you integrate one of these services with your registry, now you have something that's scanning your containers from a security standpoint and from a policy standpoint. So it's not necessarily just, am I looking at the CVE list, but am I looking at certain policies at our, certain packages at the right versions, that these are the only ones we allow? Are packages coming from the right source? So as an example, Red Hat has a container catalog that ISVs such as myself put software in to say, hey, Red Hat certified this. And to go through that process, basically a private registry, but they scan it, they look at all the various packages that are installed, they check it against policies. So like as an example, our software deploys with an RPM. At least our commercial software does. And we ran into an issue with Red Hat certification because the way we had built our RPM. The RPM works fine, but it didn't match the way Red Hat wanted to see it. And so being able to put those policies into an automated scanning makes it a lot easier. The other great thing about containers is what you ship into each environment should not change. If you think about containers on a ship, the giant boxes, they all kind of fit there. Regardless of what your configuration information is, when you design your containers, you want to do it in such a way that's external to the binaries. So they're, depending on your orchestration system, we'll talk about orchestration in a second, how you actually deploy and manage it. You don't want any configuration information in there, because if you think about it, especially from a security standpoint, how many of you have had to deal with like source code scanners looking for vulnerabilities? So got a couple of folks. The nice thing about this is when you run your scans, as long as you don't change your binary from one implementation or one environment to the other, you now have this one thing that you can scan and be secure in the fact that what you've scanned is actually what's going into production. So those are a lot of the main benefits of Docker, or to containers in general. And I think there's one on there, Docker versus LXC. Doesn't matter, to be honest, the way the industry's going. So very short history lesson just to make sure we all know where at least I'm discussing from. Docker, Big D Docker, the company started as a company called .cloud, I think is the name of it. And they were building their own platform as a service. And in order to do that, they created this concept of managing containers. Containers were not invented by Docker. They've been around for 20 years. Anybody here with a Gmail account? Right, pretty much everyone. You log into Gmail, you're using a container. Google's been using containers for 20 years, a system called Borg. A couple of really smart developers at Google said, hey, this Docker thing, really taking off. People really like it. It's a pain to orchestrate at scale. So let's take what we learned from Borg and create this thing called Kubernetes. And that's just been setting the container world on fire. Well, when that happened, the industry got a little bit of a weird shuffle because Docker, Big D Docker, who had been the darling of the industry for a couple of years now, didn't always have the best relationship with some of the other vendors in the space. And so what has happened is over the course of time, Kubernetes, OpenShift, these different orchestration platforms have been actively working to make it so that you don't have to use Docker's orchestra or Docker's container runtime. So the format has been standardized. So whether you're going to use LXC, Docker, who else? Rocket is another one. Cryo, CRI-O is the one that Kubernetes is starting to ship with. I think about 9 is going to ship with Cryo. So you can develop locally using Docker, but deploy onto any of these container formats and it'll work. Because where you're going to do your standardization is going to be around your normal protocols, right? If you're talking microservices, you're probably talking HTTPS. If you're having a lot of fun, you might be playing around gRPC. If you're talking databases, you're going to be using your standard database connection. So you're still going to standardize on that. And you're going to want to, again, externalize your configuration. So that way you've got this one bit that whether you develop it locally or you develop it as part of a large orchestration system, it all works. So to give you an example, I love containers for my development work. Once upon a time when I started doing development, what was the first thing I would do? Okay, does Yum have does Yum have this OrientDB thing that I want? Or does Yum have a TitanDB thing that I need to work with? Or does Yum have XYZ system? Now I don't bother. Docker, pull, I'm off to the races. So that's one part. The second part is by writing my software in a way that works well in containers, it's actually made it much easier to run my software anywhere. So I run a local container for my integrations, and I deploy it up to Kubernetes or I deploy it up to OpenShift or whatever's being orchestrated. So it's really made for the vast simplification of my workflow, especially given I work in identity management is a very integration focused, so I can't just like fire an app. I have to have Active Directory, I have to have ADFS, I have to have databases, I have to have directories, and that's even before I start integrating with applications themselves. And so having a lot of those things in containers makes a really big deal. I've been talking a lot. I want to take a really quick break. Anybody have any questions, comments, disagreements? Okay, cool. So, so I've mentioned Kubernetes a couple of times. Well, let's see, how am I doing on these? So let's talk a little bit about, I'm going to hold off on authentication for a second. I'll wait till I get to the presentation. So let's talk a little bit about Kubernetes, and then I'll feed into the presentation and the demo. So a lot of folks raised their hands, had heard of Kubernetes, hadn't deployed. So what is Kubernetes? Well, VMware. Folks have used the server-side edition, ESX, or whatever they're calling it these days, the mesh. You know, your VM runs on one server, and then it runs on another server, and you really aren't supposed to care. Think about that, but for containers. As the abstraction layer gets smaller and lighter weight, it's easier and easier to move and harder to manage. You get more sprawl. Where once I could run maybe 2 or 3 VMs on my laptop before it really started to slow down, I've had as much as like 15 containers running before realizing. And not just on my laptop. So you imagine an enterprise where you have hundreds of thousands of servers running VMs, running containers, that can get tough to manage after. So how do you orchestrate? And so there are multiple projects to do this. Kubernetes has basically, Docker had this thing called Swarm, great for a laptop, didn't scale. Mesosphere, with their data center OS, they had their own container orchestration system. They've recently switched over to Kubernetes. Who else? Rancher is a company that had their own scheduler. They've switched over to Kubernetes. Red Hat with, anybody ever heard of OpenShift? A couple of folks. OpenShift is Red Hat's Kubernetes distro. So it's basically become the standard for orchestration. When I talk about orchestration, what do I mean? Well, think about what we said about containers not knowing anything about configuration, right? So there are host names, there are different types of services, but if you're going to build a container that doesn't know what services are out there when you create it, how does the infrastructure? And so what the orchestrator will do is it'll do a few things. One, gives you a way to isolate your containers. So my application might be different than Andre's application. And quite frankly, I don't want Andre accessing my stuff, and Andre doesn't want me accessing his stuff. So you need some way to do isolation. The networking is all virtual. So you want a layer for software-defined networking. That's called CNI in Kubernetes. You want a management platform. You know, how do you actually manage all these different containers? And a consistent way to describe how these containers fit together. And so that's where Kubernetes comes in. And Kubernetes, it's not rocket science. I'm sure no one's made that joke here before. It's a scheduler. And by scheduler, there's a server. And that server runs off of web services. And you have nodes. And so a node comes on board and says, hey, Kubernetes, I'm alive. Give me something to work on. And then based on labels, which are basically just attributes, and different rules, Kubernetes will then go ahead and schedule where containers should run, whether those containers are long-lived or short. There are some containers that they just run and they're done. There are some containers like OpenUnison, which I'll show you in a couple of minutes, that will let you do all sorts of interesting things and are long-lived services. So, what's really nice about Kubernetes, it's open source. And there has been this kind of interesting approach to it where there are enough market pressures inside the ecosystem that everybody who is running it is a 4,000-pound gorilla. There are enough 4,000-pound gorillas to keep each other in check. And so you haven't seen the fragmentation that you did with other open platforms. And you also haven't seen quite as much vendor specificity. And because there's a lot of room inside of Kubernetes for opinions, different vendors come to the fold with different opinions. Some of the areas where the opinions are really interesting is around storage. How do you access systems? Stateful. Containers were first kind of conceived in stateless web servers, right? Web servers are stateless for the most part. But if you want to run your database in a container, that becomes really interesting. And then networking and security. So let's see here. How are we doing on time? We're doing good.
Yeah,
so
we have the room to.
Oh, okay, cool. So yeah, so please, yeah, please.
So you just brought up that Kubernetes allows you to dictate what's outside there.
Mm-hmm.
In programming, we have mock objects.
Yep.
Is there already, I'm assuming, a way of having a mock container so that I don't have to, okay, the system's down, like you said, the network,
Yep.
all these different use cases. I think of 100 of them that I could just do that without even going to build another container and then having the code there.
So sort of. So the way that you design your container, turns out that if you design your container real well, it's not that different from designing your application. DNS thing. So Kubernetes has a built-in DNS system. So the idea being that if you attach things to a certain name, you can know that that name is there, even though it might not be deployed quite yet. But it doesn't do the facade type objects that you might be. So if you're talking to a database and you're developing against it, you still need to have a database.
I understand that. When you're talking about almost like a network as software, that's where I was starting to think of, okay, there's a lot of stuff that can go wrong in that. And if you can make something that says, okay, this use case, this component breaks, this component breaks, and the second use case, instead of going off and writing all this code and just almost, that would be really cool.
And that's actually kind of how it works. So there are kind of two aspects to that. One, the networking stuff is all transparent to you as the programmer. So as far as you're concerned, you're just going to do your network. If your app opens up a TCP/IP connection, you're just going to open it up. If your app opens up a web connection, or is doing something over WebSockets or whatever other funky thing that you might do, it's transparent to you. That all happens at the orchestration layer. And the way that works is through what's called the CNI. Common networking interface, I think it's called. And there are kind of two different ways that that's done. One is through what's called an overlay. So you've got your networking, your wires, your routers, everything. You probably have an SDN already defined at the VMware layer, because you're probably not running on bare metal. And then it will literally, just like it sounds, overlay on top of it. So it adds a layer on top to handle that routing. There's scalability. There's a lot of power in overlays. There's some scalability issues though, because you're adding yet another layer. And then you can also piggyback off of the existing network layer. So VMware just announced a partnership with Cloud Foundry. I think it was a couple months ago, where you can use a lot of the VMware infrastructure that you already have as your network infrastructure. So that part's transparent. Now, when it comes to actually assembling applications, and when I say assembling applications, and mind you, Kubernetes was designed with a microservices idea where you've got all these different web services that you're going to bring together as an application. The idea is that you define a pod, which holds your container, possibly multiple containers, and then a service on top of that. So that defines how things will talk to your application, you know, assuming some kind of web service. And then you define a way to access it from the outside world. So what that lets you do is say, okay, think about like a red-green deployment, or a green-blue deployment, where you're doing an upgrade. Because that service layer is between the caller and your application, you can roll out, you can tell Kubernetes to do half of your deployments as the new version, see what happens, pull it back, and it's all transparent to the callers. So it doesn't eliminate the need to have your infrastructure in place to talk to these different things, but does add a layer of separation where if you have a tool that generates mock responses, you can be confident that you're going to be calling it the same way as a real system. Does that help answer? Thank you.
Maybe we can get to it later. I added to the docs, but Rancher, tools like Rancher, right? Management tools around Kubernetes, that layer. I'm not sure where you want to fit it in. Any thoughts on those?
This is probably a good time. So it's a great question. So anybody here ever hear of a guy named Kelsey Hightower? So Kelsey Hightower is kind of the rock star in the Kubernetes world. He's a developer advocate at Google, and just all around nice guy. I got a chance to meet him last week for the first time. And he talks about opinions. You know, software has opinions. And Kubernetes on its own tries not to have a lot of opinions. It tries to leave opinions to implement. I would highly recommend never running Kubernetes from the website on your own for anything but a POC. Kubernetes is the framework, but you need things to plug into it to make it work. You need the networking layer. You need the networking layer. You need the registry system. You need the identity and access management, security, storage, logging, and that's just like right off the bat. And those things are not provided for you by standard Kubernetes. That's where things like Rancher come in. I'll be honest, I never worked with Rancher, so I can't give any feedback on that system specifically. But you've got Rancher, you've got Tectonic from a company called CoreOS, OpenShift from Red Hat, and all, just to make sure that everything's above board. I will be honest, I'm a big OpenShift component. My company is a big Red Hat partner, so I'm a huge fan of OpenShift personally and professionally. And then you've got the cloud-based versions, right? Amazon just announced their version of Kubernetes. Azure has their own managed Kubernetes, and then Google was the first to come to market. So I would go with one of those, myriad of options. Which one you go with will depend on whether or not their implementation, their opinions match your own. So kind of as an example, OpenShift is very heavy. Just to get up and running, you're talking about, I think, 15 VMs if you want to do it highly available. You've got your masters, you've got your infrastructure nodes, you've got your worker nodes, and then you've got your etcd servers. But once you're up and running, you now have an environment that, as long as its opinions match your own, which OpenShift is usually multi-tenant, so multiple people are logging in, centralized logging through the EKS stack. Maybe you want to be able to go cross-cloud, or you don't want to rely on a particular cloud, and you're building things kind of on your own. Those are good opinions if that line up with OpenShift. Now, let's say you're an AWS customer and you love using AWS services. You want to minimize the amount of services that you have to run on your own, right? AWS is an EKS stack. AWS has a database. AWS has an IAM system through identity and access management. So you want to minimize that. Well, that might be the better route to go, and same thing with Azure and Google. So really, which one you go with is going to depend on which opinions you like. I've talked to folks that I was actually just talking to someone earlier this week that said, you know, OpenShift is interesting, but I don't like how they hide Kubernetes under the covers. If that's your opinion, then you know OpenShift's probably not a good approach if you want to use standard Kubernetes. You know, Kubernetes or the CNCF, the Cloud Native Computing Foundation, just launched a certification program. So you run SonarBuoy, which is one of the certification tools out there, against your cluster. You know, your environment. If you make either something that works with Kubernetes or a flavor of Kubernetes, and as long as it passes, you get that CNCF seal. So they're working very hard to try and make sure that there isn't a lot of segmentation in the market, and focus on the varying opinions on how this stuff gets implemented. Does that answer your question?
Yeah,
cool. So what I'm going to do is I kind of want to. I've talked a lot about abstract ideas. So I'm actually going to take you through a deployment of what it looks like to build a container, what that container ends up doing. And before I even dive into that, one of the downsides of a container is it's static. You have a static Docker file. You can do some ninja moves with, you know, the run command to do all sorts of stuff in there. But at the end of the day, it's you build it and that's it. My software, at least, is not that static. I think most software is. So Red Hat came out with this idea called source to image. And since then, there have been a lot of variations on the theme. But ways to make more complex Docker. So the way source to image works is you have what's called a builder image. It knows how to interpret some kind of source code. Sometimes it's just as simple as copying files. So like you talk about Node or Python, and it just has the baseline container runtimes on there. Sometimes if you're like talking about Java or Go or other compiled languages, it's got to know how to actually build it and then generate a Docker image that is compressed so they take away all the fluff that various layers aren't needed, and they push it into your private registry. That's why I used to build my stuff for the most part. I like it. Builda is another project from Red Hat that is working on that. There's another one from Heptio, KSonnet, I believe it's called, for orchestrating and putting these things together. So this is an area where a lot of people are really starting to spend a lot of time. So there's a lot of movement. So let's go ahead and come over here and let's go through the process of what it looks like. So can I zoom in? Yes. Up there? Cool. Okay. So the first thing I did was, this is actually already running. So let me just grep S2I. Okay. So I'm going to try and make this a little bit smaller so you can see it. So this is where the first bit of magic is happening. So S2I, that's the executable. It's a binary that does the magic. I'm telling it to do a build, and I'm basing it off of this project. Now, it's kind of boring to watch Maven build go for 10 minutes, so I'm not going to do it off of Git. But if I wanted to put in a Git repository there, same idea. It would just pull it right out of Git and do a build. And then this part here, this might be a little bit easier way to do it than pointing on the screen. This is the output of the container. So I'm going to create a container in my local Docker instance. Ideally, this would be some kind of CI/CD pipeline called localhost :5000/Tremolo Security /open unison K8s. This first part, the localhost :5000, that refers to my registry. So I always recommend having a separate registry. You can use Docker Hub. Couple of things to remember about Docker Hub. One, it's open. Everything's out there. Two, if you're using a non-free OS, so if you're using RHEL or you're using like Oracle Linux or something that you have to pay for, they do constant scans for that. They find it, they take it down. And three, you need an internet connection. So I've gotten into the habit of just running my own local registry. Pretty much all of the Kubernetes distros that are out there have some kind of built-in registry, and that's part of their opinions. And the nice thing about that is, going back to earlier in the discussion, let's say you have security policies you want to match. You have packages, back to the scanning. If you have your own trusted registry, like anything else, that's where you can now do all of that instead of saying, okay, well, do I have to go out to Docker Hub or Docker Store or whatnot? Everything gets pulled into the central registry. And so that's what that first part is. I've got a registry running in a container here locally. Docker has this idea of tags. So let's say I were to call this just Open Unison K8s, forget the local host and the Tremolo Security. I could do that, do the build, and then later say, tag that build with this name. I'm lazy, I'd like to do as few commands as possible. Tremolo Security, so that's just a bucket basically inside of the registry, and then finally the name of the container, Open Unison K8s. So what this is going to do is it's going to take the input, which is a existing container, the docker.io Tremolo Security Open Unison S2I Docker :latest. So that is an image that is up on Docker Hub. I've got it pulled down locally to make my own life easier. That's my builder image. So that knows how to take the WAR file and then build an Open Unison image, and then I can then go ahead and push it. Helps if I actually ran that right. I can then go ahead and push it. So what's happening here is it's talking to S2I is talking to Docker. It's finding a WAR file that I've already created. Had I passed it in a Git handle or a source code repository, it would actually just go ahead and do the Java build. But that takes like 15 minutes. That'd be kind of boring to watch. So now it's created this local host, this Docker file called Docker image called localhost 5000. So now the next thing I'm going to want to do is push it. So you see here this Docker push. So what's happening is you'll see this layer already exists. This is one of the fun parts about Docker. This bottom layer, this is the CentOS base layer. That hasn't changed. There are a bunch of other layers in here that haven't changed. They're basically just metadata, they're small. This final layer, it's gone by already, but you saw it was about 200 meg. That's the WAR file. That's the part that I created that's new. So when I pushed it, the only thing that went into the registry, because these are all hashed, is this top layer. Because Docker already realized, wait a minute, I already got all these. It's a one-way hash, so we know it's unique. So I'm just going to push this part in. I'm not going to bother clogging up network space and disk space by having to have multiple repositories out there. So now that that's done, I'm actually going to do something here real quick. I'm going to do a quick reboot on these. So I've actually got Kubernetes running on here. And, no, that's not going to work. Oops. And then we'll do the same thing with the node. So So now I've got a container. How do I get that container into Kubernetes? And so this is where Adam, let Adam fire up here. So this is where things get kind of interesting, because how do you go from that Docker file, which is just the static thing, into a, do I have the, no, I don't. Reopen project. Here we go. So inside of Kubernetes, you end up defining these different types of things called services. So let me pull that up. Quick start Kubernetes YAML. So this is deployment. And deployment mixes most aspects of what you're going to care about. The first is going to be just where are you getting the information from? You know, where are you getting your container from? So this is our private registry. So that 192.168.56.1, that's the VirtualBox network interface going to my local host. Everything's running inside of VMs on my machine. So what that's actually saying is, for this deployment, pull my container that I just deployed into that registry. Then we've got a couple of scripts to check liveness and to check availability. So container might take a couple seconds to come up and running. You want to know that it's up and running before you let things start coming in and accessing it. And the liveness is it still working properly? And so that's how a lot of Kubernetes services work, is just, you know, tell me how to know your application is working so I can test it. And then you have the service layer. And the service layer just defines who has what, who has access to, or from a networking standpoint. You know, what's really interesting about Kubernetes is, take a look at the metadata where it says labels, app open unison. That actually is how you link these things together, is with these labels. So you define a service called Open Unison, you say it links to a deployment named Open Unison, and the labels match up. So now if you want to point it to something else, you just fire up a new deployment, different label, and then when that's up and running, you just tell your service, talk to this different label. Everything's transparent. So this thing's probably done rebooting. I'm actually going to go ahead and fire up so we can talk about the compliance aspect. Slides.google.com. That is so not where I wanted to go. Yeah. I don't know what that was, and I probably don't want to. So this is my KubeCon presentation I did last week, and this actually gets into a lot of the security and operational aspects from a compliance standpoint. Come on, Google, you can do it. There we go. So I probably don't have to spend a lot of time on this slide. You know, what is compliance? Here, it's the various NIST offerings, right? You know, specifically, I was talking about identity management. Who has access to what? Already gone through that. So why is compliance important? Especially in the DevOps world, and that's why I want to spend a second on this. You know, there's two aspects to compliance being important. There's the carrot and the stick. The stick, often because people who don't want to let a disruptive technology in will tell you, oh, you're not compliant, so go away. So that's one aspect of it. But then the other aspect is, it turns out that if you don't treat compliance like a checkbox, and you really try and attack compliance from a DevOps perspective, it actually make everybody happy. You know, this is my little formula here. You add DevOps and identity management, and you make your suits and your developers happy. Suits don't really like having to manually add users to groups. Auditors don't like digging through emails, contrary to popular belief. So, this is probably going to be pretty obvious to most of the folks in the room. NIST 853 is really a framework. It's not a prescribed checklist. So first you define your policy, then you actually have to act on it. And so here, whereas IDM fit in, AC-2 is one of the first identity management related controls. It's kind of a palindrome, right? Authorized access based on an access authorization. That's super helpful. But basically what that means, you have to have a policy as to how you define access. Usually that's some variant of the system owner needs to approve it, your manager needs to approve it, or both need to approve it. And then you would use identity management there. So compliance without, or IDM compliance without DevOps. So let's talk about Kubernetes. If you're in a multi-user environment, you'll usually break things up by namespace. And so if you think about namespaces like your project, your fiefdom, your domain. Well, who has access to that domain as a developer? New developer comes on the team, new ops person comes on the team. How do you manage who has that access? Well, I call this the email shuffle. I email someone who says, hey, I need access to this. How do I get it? Forward it on to the admin, says I approved, the admin does it. Hopefully it worked. But as we've proven today, sacrificing to the gods isn't always the right thing to do if you don't get the right gods to sacrifice to. And so sometimes it just doesn't work. And so now you have unhappy users and unhappy admins who have better things to do. And okay, FSMA audit time. Let's start digging through all those emails. Nobody's happy in this situation. So let's add compliance and identity management to this self-service. User needs access to your namespace. They ask for access to the namespace. Log into the IDM system. And if the demo gods are happy with me, that's what I'll show you here. Namespace owner approves it. You define a workflow. Go ahead and provision that access. And then finally, the auditors get to see a report. Notice the word admin doesn't exist anywhere on here. Admins have better things to do. So how does this all apply to Kubernetes? We talked a lot about Kubernetes. This is how we get to identity management. Who are you? What are you? Why can you do it? So in Kubernetes, who are you? Certificates. That's the most popular way to do it. I'm not a huge fan. Even in this town where everybody wants to do PIV. The reason being that, well, one, I don't want to have to generate credentials. Two, the Kubernetes API server is just a web server for all intents and purposes. And going back to compliance as a stick, if you need to run it with certificates, think about that. You can't go through the web application firewall. You probably have to configure your NetScaler or F5 just a little bit differently because you can't have a TLS termination point. TLS has to go through directly to the API server. So, okay. That's on the authentication side. On the authorization side, the way Kubernetes does authorization, which I'll get into a little more detail in a second here. You have a role and you have a role binding. In order for a certificate to push roles into Kubernetes, they have to be OUs in the subject of the DN that's on the certificate. So if you think about a 5-year-old certificate, that can get messy really quick. How do you deauthorize that? So I'm actually not a huge fan of certificates. I like OpenID Connect, which is a web service set. How many folks here have used OpenID Connect? Okay, SAML? Okay, OpenID Connect is a lot like SAML, except it's JSON, and it is very popular for internet-based identity providers. So if you ever clicked on sign on with Google, you ever clicked on sign on with, I'm technically not Facebook, but I think Twitter and LinkedIn, that's using OpenID Connect. And the nice thing about that is it's just like a SAML assertion, it's short-lived, and you can put whatever you want in it, including your groups. So, and as of the latest NIST 863 revision, it is a valid token from a compliance standpoint. So that's actually new. You can use a reverse proxy and inject a header, though from a compliance standpoint, that's kind of hard to deal with. Also, if you believe in the concept that network borders don't really work, perimeter security doesn't really work, then you're now letting anybody assert who has access. And then finally, there's a way to do custom authentication. Don't. Just don't do it. Every time I get into a conversation where they say, well, I don't want to deal with OpenID Connect, I want something simple. As I talk through with them what they want to do, over the course of 10 or 15 minutes, it basically just becomes OpenID Connect. So chances are, unless you have a really specialized reason, don't do custom authentication. Examples of where you would do custom authentication, Google's Kubernetes offering integrates with Google's own authentication system. That makes sense, right? But if just on your own you're going to do an enterprise deployment, there's no point. So the what do you have access to? So an authorization in Kubernetes is a combination of subject, a role, and a namespace. So namespace is a place, right? A fiefdom. A role is the definition of what you can do. So what APIs you have access to and what verbs, like get, put, push, stuff like that. And finally, the role binding is what pulls them together. There are no groups in Kubernetes. So there isn't even a concept of a user in Kubernetes. Unless you're using a service token, users have to be asserted through the authentication process. So when you log in, when you authenticate to Kubernetes web service using your certificate, that entire transaction sits on its own. There's no session. There's nothing. So it pulls the DNS certificate, maps it to role bindings, and you're off to the races. Same thing with OpenID Connect. So you have to assert everything inside of your, oops, wait, oh, sorry, on laptop. Can we still see? Yeah. Oops. Okay, cool. So I promised you a demo, and hopefully you guys will be with me. So this is the demo environment I have set up running on my laptop. We've got Kubernetes running. Kubernetes is running Open Unison, which is our software, our open source identity management platform. We do more than just Kubernetes, but Kubernetes is fun, so we thought we'd start with that. And so what we're going to provide is, we went back to that slide, that DevOps slide, self-service, making sure that people, self-service, you don't want admins having to manually do things. You want to automate everything. So that's all running inside of Open Unison. We've got a database that stores the audit data, that stores the authorization data. We're managing groups. And then we have a way to be able to onboard namespaces. So with that, let's fire up the demo. Let's hope it's still working. I don't really need this iPad anymore, so there's no point in keeping it up here. So what's happening is I'm logging in. Now this is actually running inside of Kubernetes. So bounced past really quickly, but what happened was I logged in and it bounced me over to ADFS via SAML2. I authenticated, I came back to Kubernetes. Now, one of the things that's interesting about Kubernetes is it's a web service. And so to interact with that web service, you need something, right? So there's kube control, excuse me, that beta has been settled, which is the command line interface, which just calls the web services. All it does is inject your token into those requests. So you need a token first to give kube control. And because kube control is a command line interface, it doesn't know how to interact with the browser. There's no way of knowing how to do that. And there's probably no secure way to do it, to be honest. So what we did was we said, okay, let's go ahead and generate a kube config for you so that you can just drop it in and go. So we maintain the OpenID Connect session with Kubernetes. So we've authenticated you via ADFS, and I want to go over to the dashboard. See if this actually works. Please work. Be nice if you worked. There we go. ADFS, sorry, good question. application or Active Directory Federation services. I do a lot of work in state and local, and ADFS is like the SAML 2 implementation choice where you're not dealing with PIV cards. I don't run into it quite as much in the federal space, but a fair amount there. And so the thing to remember about identity data, especially when it comes to anything that you own as a developer or as an implementer, is that the people who own the identity data are not the same people who need it. And so if you need to be able to read identity data, whether it's out of Active Directory or from ADFS, that's usually pretty easy. Where things get hard is rights. And so what I always say is separate it out. Keep your authorization data and attributes in one store, and then leverage Active Directory where you need to. And then that gives you that separation where you can control as much data as you have. So like here, the Kubernetes dashboard, you see I log in, and this particular user, M. Mosley, has access to everything. So I can go into any namespace I want. Does this project actually exist? It does. And I can start to do things. So that's the Kubernetes dashboard. Going back to the Rancher question, this is the stock dashboard, as it's called. It's a separate project. There's probably half a dozen open source dashboard projects out there, all with their own opinions. And then pretty much every commercial implementation of Kubernetes you buy has its own take on what should be in there. The other thing I'll bring up is our tokens. So when I talked about using kube control before, you want to be able to use the kube control command. Very few people like to use the dashboard for a lot of things. And so Open Unison, which is our open source package, let me go ahead, do this, make this bigger. Export path gets MLB Kubernetes client bin path. So I'm going to go ahead and run that big giant kube control command. And so what that's done is that's set up my local config so I can start talking to the cluster. So get nodes. And so what's actually happening is that now it's talking, my command line interface is now talking to Kubernetes as me, M. Mosley. So now the question becomes, okay, new user comes in, what do they do? How do they get access to something? So this is, again, where I talk about DevOps and identity management. Yeah. Waiting. So I'm logging out of ADFS here. And okay, let's see if why didn't you log out? Log out. Okay, so now I'm logged out. So I'm going to log in as a different user. And if I didn't point this out earlier, what you're seeing here is the container that I built and had pushed into the registry earlier. So that's kind of that whole life cycle. And so now I'm logged in as J Jackson, or D user, excuse me. And when I go into the dashboard, you'll see that it's going to complain. And it's going to complain because I don't have access to a lot of things. Dashboard right now isn't really well written from a identity standpoint, because even though you can, it will work with who you are, it doesn't know how to prefetch things, like only list things that the user has access to. So you'll see that it's limiting down. It's trying to access things that I don't have access to. And of course, federal environment, that becomes really important, because when you start talking about FISMA audits, you need to be able to show that you are enforcing those authorization rules that were defined by your NIST 863 implementation. So now the question becomes, how do I get access to stuff? So I'm going to do two things here. This is one of the great things about API management. If everything's an API, you can manipulate and do stuff with it. So here, what we're actually going to do is we're going to request a new project get created, a new namespace get created. That new namespace is going to include stuff I want in it, but also it's going to include all of the authorizations that are needed so that I can add users to the namespace. So we'll call this NASA demo. NASA demo. So I'm going to submit that request, and then this is where the DevOps automation comes in. Where without automation, this would be an email process or maybe submitting a ticket. Here, what we've done is automated it so that now I'm going to log in as my super user, Matt Mosley. Come on, little laptop. I think I can. I think I can. Should have turned off LastPass before the demo. So and you can see I've got these open approvals here. I want to be able to create this namespace. So I'm going to review it. You know, so this workflow, you can imagine, could be you know, that classic two-stage, my manager, then the system owner. So I'm going to confirm the access, and then as this decision is being submitted, I go over here to my reports, and I check out the audit reports, and I go to completed approvals. And if everything went right, there it is. So Matt approved the creation. And then if I go to audit reports changelog for period, we'll do the same thing. Oops. Reports. Changelog for period. 14th, 16th. Uh-oh. Hopefully that actually worked. All right. Let's go to request access. Yeah, looks like something's not working. Well, had it worked. Apparently I didn't sacrifice the right gods again. We've created a new namespace inside of Kubernetes. I can take a look at the logs later. But the idea here being that you know, you're interacting directly with the API server. My guess is that I've got some kind of time offset on here. But you're able to present reports. So when your auditors come to town, so like if I come here to that changelog for period, now let's open it up. You'll see here that we've actually onboarded all sorts of different attributes and groups. So everything's tied together. These are reports that you can generate. And the idea being that now your auditor has something to look at rather than having you dig through the objects. So let's come back here. So here, I think some interesting resources specifically on identity management. So PodCuddle episode 15, which is where this presentation all started. The authentication docs on Kubernetes. if you are interested in how the different certificate authorities in Kubernetes work, that's a really good blog. And then my original blog post that started this particular set of demonstrations on how identity management and compliance work in OpenShift and Kubernetes. A little bit of shameless self-promotion. That's our website. If you want to hit me up on Twitter, I love talking Twitter. And then up on GitHub, our various open source projects. And that's it. I know we have covered a lot. Any questions?
Docker, you're running it. You get to the actual container. You're running as root.
No, not anymore. You do not. It is very frowned upon to run your container as root. And in fact, most certification programs will make sure you're not.
Change it.
You're not running as a root process. That was true in the earlier days, but now your process is not running as root. A Docker container process is no different than any other process on your machine. To the machine, like if I'm I'll show you here. Let me log into my Kate's node. Kate's at 192.168.150, I think. Maybe. There we go. So if I go ahead and run PS all into grep Java. So that's actually the Open Unison instance. So as far as, even though that's running inside of a container, as far as Linux is concerned, because the containers don't really exist, they're just a collection of different systems inside of Linux. So as far as Linux is concerned, it's just a process. That process is not running as root. It's running as this 431. So yeah, I don't have root access.
Second question, okay, for the scanners, which ones do you like? Okay, doing CVE, one of the things that has been discussed is no one has a really good idea of, for us in the government, what scanners, since you do advocate having your own repository for compliance, you know, what scanners are really good for looking inside?
Yeah. Oh, sorry.
Do scanners check what's in this package, or are they more concentrated on how things get built? With layers, I'm guessing what would really stop you from, you know, like, okay, you scan it at the, let's say, top layer, but what's stopping you from then after being scanned, backing off a layer or two, or adding a layer or whatever, adding layers, and then running that?
So
I mean, I can basically dodge all the scanners I want and, you know, keep the auditors happy. Yeah, keep doing stupid things as I want.
So great questions. So to the first one, I'm a big fan of a company called Anchor.io. They have some really interesting scanning technology, and what I really like about them is that they aren't just looking at the straight up CVE list. They're applying a little bit of intelligence to it. So I'll give you an example. When I submitted my container to Docker for its store, they ran it through a CVE scan, and the thing looked like a Christmas tree with all sorts of vulnerabilities. Now, I patch everything. Every time I do a release, I find the new versions, I integrate them, I make sure they work. So every release, I'm always at the latest version that's publicly available. And so this was really surprising to me, really confusing to me. Then I went through Red Hat's process, and they're like, no, you're perfect. Wait, I'm really missing something here, because the exact same software I'm being told by two different sources is completely, you know, one is telling me that, you know, I'm patient 0. The other's telling me that I'm perfect. What's the delta? And Anchor.io wrote a great blog on this, specifically because I was complaining about this. saying, you know, we ran your scan through the container, and the reason why ours is saying you're good is because when Docker does their look at the CVE, they're just doing very simple text-based searches. So if I have Jackson, which is a Java library, at the right version, and it has a CVE, it's going to light up. Or if I have a package and the same version, it's going to light up. Whereas Red Hat has additional information about CVEs that says, you know, yes, we're running a version that's covered by a CVE, but we've patched it in order to mitigate the risk. And so the fact that Anchor.io is smart enough to say, okay, this is coming from Red Hat.
But basically checking against the OS specific version numbers, not their version.
Exactly. Twistlock is one that I have customers that are working with. I've not worked with it personally. I know it's very popular. But those are the two that I come across the most. Now back to your question on registries or on layers. That's why you have to have a lockdown registry, because once it's been pushed into the registry and scanned, you better know who's making any changes to that container. So if your registry is locked down,
Would it be better to scan or committing it, or every time you pull something in the registry?
usually what you'll do is you'll have it multi-hop. So you'll have a staging registry where you can do your initial scans and then move it along the CI/CD pipeline. Yeah. Oh, Swarm's dead. So the security features are that there are some, and that's pluggable. You know, it uses pretty good base assumptions around security. Everything now, all the deployers are done. You know, everything's encrypted. It's moving towards more and more externalization. So, you know, things like HashiCorp Vault, being able to externalize secrets, stuff like that. Swarm worked great on a laptop, but once you got into enterprise, it wasn't able to do the job. And quite frankly, Swarm's going to be abandoned by Docker in the next year or two anyway. Yeah, Docker's picked up Kubernetes. They've made their first release of Kubernetes. They wanted to do for Kubernetes what they did for containers, which could be very interesting because they did an amazing job making it easy to use containers. So I'll be interested to see what they do. I haven't had a chance to play with it, but yeah, Kubernetes won. I mean, until something new comes out that really knocks off everybody's socks, it won that particular registration war.
You've been around to various government versions, that sort of thing. What's the adoption rate of like Kubernetes and Docker and other government agencies? What have you been seeing?
So there have been some public ones. USCIS has recently adopted OpenShift. GSA has been doing work with Docker. They were actually one of the first Docker EE customers. I find it absolutely amazing the rate of change in IT in general in the last several years. I think a lot of that has to do with the fact that public cloud is now very popular. And once you have public cloud, you've eliminated a lot of the barriers that it took to even just get a VM, right? For better or worse. So, you know, the rule of thumb used to be 7 years. The federal government is 7 years behind private industry in IT. That's shortening. Don't talk about it as much because the government, we're not supposed to talk about these things. But yeah, I've definitely seen it get more and more adopted, especially when you can tie back the idea that I can shorten the time from when a vulnerability is announced to when it is tested, patched, and deployed because I have a shorter deployment window. Whereas with a lot of legacy systems, all right, yeah, this, all these other things. Whereas if you have a container and you've built your software around containers, you typically have a much faster deployment time. And that at least seems to be a big part of the value proposition of containers is it makes the security people really happy.
But the video will look better than this. It actually affected policy. I'll try to include as much notes as I can. If you have any other questions after that, put the questions in. I'll take questions on the fly.
You get access to your presentations. You had a
Oh yeah, absolutely. I'll send Andre the link, and then this actual demo and everything that I did actually worked when I did at KubeCon last week. They haven't published it yet, but that was video recorded. So I'll go ahead and shoot Andre the link for that as well. And on our website, on tremelosecurity.com, we've got a ton of different videos that are very similar. Kind of how I figured out how all this Kubernetes stuff works. I kind of videotaped all of it along the way. So it's probably also useful from just a straight up, how does this stuff work standpoint.
Thanks, guys. Thanks, Mark.
Awesome. Thanks, everybody. Okay, so it wasn't just me. Okay. It's like, wow, I'm cold. Oh, thanks for having me. Sorry it didn't go quite as smoothly as I had hoped.
It went, right? I mean, that was good.